There's Stephanie. Still waiting on a few more. And at this point now, the computer completely refuses to connect to the projector. As soon as I plug in that HDMI cable, not only does it not give me a screen there, it shuts down this monitor, which makes no sense to me whatsoever. In order for you to have a visual and able to follow along, you in class also need to join the Zoom call. And just mute everything so you can see it, so you can see my screen on your screen. No, unfortunately, we don't completely get out of class for that. Speaking of, we got to get started here. All right, everybody suddenly poured in at the same time. So, Perla's there, Brianna's there, and Naomi, and I'm only missing Lewis. I mean, if you want to be able to see what I'm writing and actually talking about, then yes. Because the projector is not cooperating this week. Most unfortunate.
Is the fire alarm going off at the school?
All right. Hello, guest on the YouTube chat. I am not Mr. Jacobs. You are at the wrong class. All right. So, good morning, everybody. Today, we get to talk about one of, I don't know about top 5, maybe top 10, favorite things in math. Okay? What? No, it's not fractions. I know. All right. So before we get to my favorite thing, let's go back to yesterday's rational root theorem. Run through those answers real quick. Okay, now we got 2 cameras?
Yes, sir.
All right, good.
Yo, bro.
Anyways, here are the answers for yesterday's worksheet. Do you really need the speakers on? Okay. So I'm just going to flip through those relatively quickly. Go ahead and check your work if you haven't already. Maybe. That can be like a winter break project, perhaps.
Yeah, like you do a fraction.
Yeah. I mean, like over winter break, that could be something. The Minecraft thing. All right. Does anyone have any questions on this worksheet? Questions over Zoom?
Yo, I actually have a question on it. So basically, I kept getting a lot of numbers, right?
Yep.
So let's say there was a negative, I had to do a positive, then a negative, and then a positive and a negative for the other one, right? That works. So let's say there's a negative 3, right? Let's say the factors of it is like negative 3 and 1, but also 3 and negative.
Yeah, so you're always going to have both the positive and negative options in the end. So I would say the easiest way to think about it is to ignore the signs at the beginning and just look at the number and what factors are that. And then use your combination of P over Q, simplify those ratios, and then that final list, go ahead and add the positive negative. So just like he did in the video, save the adding positive negative for the very end. because then you only have to apply it once, and you only have to think about it once. So yeah, if the number presented in the function is -3, just treat it as a 3. Factors are 1 and 3. Okay? All right. Very good. Any other questions? No? All right. Then what we're going to talk about today is how to use synthetic division to make use of this list. So this rational root theorem gave us a list of numbers that could be the roots. And then we needed a way to test them. You could try like plugging each of them in alternatively, but it's much faster if we could divide each of them out, because as we discover one root, if you divide it out, you simplify your polynomial. You make it smaller and smaller and smaller, which means as you go, you have less and less work to do to find each subsequent root. It's going to save us a lot of time. So, here we go. Just a quick introduction. The idea of solving by division has to do with that, I think they call it the remainder theorem, right? If a function divided by some factor has no remainder, you do the division and you get no leftovers. It divides evenly and perfectly. Then that is a factor. If in the form of x minus b, it's a factor, and then x equal b is a root. You have now found one of the roots.
I got a question. Should we be taking notes?
I would write that down. That seems pretty good stuff to know. So I'm going to start with a really simple example. I'm not moving anything. Not moving anything. Just explaining. So notice this function here, let f of x equal x minus 1 times x minus 2 times x plus 2. It's already in factored form. So this is going to seem ridiculously simple, because I want to explain that concept, just this part of finding no remainder, verifying it's a factor, and a root. And then we'll introduce the technique for what to do when it's not already in factored form, which would be most of the time. Ah, there's Lewis. All right, take a look at that function. F of x equals x minus 1 times x minus 2 times x plus 2. Is x minus 2 a factor? I mean, I know we already know it because it's in factored form and it's written right there for us. Yes, but we can verify that by testing. Divide f of x by that potential factor. And in this case, it's going to simplify quickly and easily. Oh, come on, give me a better line. There we go. Because we can see I've got that same factor on the top and the bottom, right? They just divide out, reduce that. My answer is x minus 1 times x plus 2. If there was a remainder to be written, it would be 0, right? I have no leftovers. It divided out cleanly. So therefore, yes, x minus 2 is a factor, and therefore, we solve if x minus 2 is a factor, set that equal to 0, solve for x, add 2 to both sides, x equals 2 is a root. And we could test that even further. Want to like triple check at this point. If you plug 2 into the original function, will the whole thing turn to 0? Right? Absolutely. The tricky part comes in because they're not always given to us in factored form, but we want to reproduce that same result, right? We still want to divide, and if we get no remainder, call it a root. So here is one of those from the last sheet. I think this was number 9. Right? So when we test for our rational roots, we get positive, negative 1, and 3. Right? Let's go back to this color. So our P's over Q's ended up being positive, negative 1, and positive, negative 3, right? This isn't in factored form. I can't just see immediately, oh, if I divide by x minus 1, that'll drop out, and I'll have a solution. I don't know which ones will work yet. So one option was to plug each of those numbers in. And that works fairly well. And when you have a short list, it can be not too bad. All right, I've got 4 different numbers to try in a third degree, 1, 2, 3, 4 quadrinomial. Right? That's not too much work. But if you use division, notice how up here I started with 3 terms. When I divided it out, I'm now left with only 2 factors. It's now a quadratic instead of a cubic. My polynomial gets simpler. So if I can test one of these via division, in order to test for the next one, because I want to find all of them, right? Not just check for one. I want to find all of them. The next check will be simpler. So I'm gonna cheat a little bit. They tell us one of them is negative 3 and one of them is 1. Let's try it with positive 1 first. You could go the long way, right? The long way would be literally long division. X minus 1 goes into x cubed plus x squared minus 5x plus 3. And that is awful. It's horrendous. I hate it. Totally honest with you. I don't like this method. I never use this. However, let's keep in mind, long division always works no matter what type of root. You can divide, 2x squared minus 1 out of here if you wanted to. You could attempt that. You could work through it. And the process doesn't have to change. Okay? So long division is useful for that reason. But I much prefer synthetic division because it's way faster and cleaner. I'm gonna jump to another example here just to show you side by side the difference, right? On the left there you see a long division. On the right there you see a synthetic division. Look how much less stuff there is. Look how much shorter and faster and easier that looks. Isn't that like just immediately more appealing? No? You'd rather write x squared 10 times? Well, okay. Assuming you have to answer the question somehow. This is way better. So what we're going to do is, as always, make sure this is in standard form. We'll start with the highest power. And I'm going to rewrite that function with only the coefficients. Remember, if you don't see one, it's an invisible 1. And then next I have another invisible 1. And then negative 5, and then 3. Okay. I am dividing by what is the root I'm looking for. Let's test positive 1. Is positive 1 one of the roots? Set up a line for your answers down here. You're going to bring down the 1. And then instead of actually dividing, long division involves dividing and subtracting stuff. Synthetic division involves multiplying and adding stuff, which for most people's brains comes a little bit easier, at the very least. And then you multiply that out by several times they have to do it, and it's going to save you a lot of time. You're writing fewer things at once, saving you a lot of time. This is way faster. And that is why it is one of my favorite mathematical things, techniques, because it's such amazing savings. Okay? Look how fast we can do this. Well, this one's going to be extra fast because there's a lot of ones. So bring down the first one. And then this one times that one up there is 1. And so we write the answer here. And now we add vertically. 1 plus 1 is 2. And then we take this and we multiply by our root again. 2 times 1 is 2. Add vertically again. 2 plus negative 5 is negative 3. Negative 3 times 1 is negative 3. Add vertically again. 3 plus negative 3 is 0. This last number right here is our remainder. And if it was 0, we win. We found it. This is, in fact, a root. It worked. Now, if you are finished there and you want to convert the rest of your answer back to a function, check what power you started with. I started with a cubic. Reduce that by 1, and then assign descending powers of x to every coefficient there. So that 1 becomes 1x squared, that 2 becomes 2x, and then minus 3 is our constant. So that's our quotient, right? F of x divided by, here, I'm going to move this over a little bit. Divided by x minus 1 equals that. All right? And now you only have a quadratic to deal with. Maybe at this point you could say, oh, well, that's just a quadratic. I could actually factor that quadratic, and you could go from there, right? Or we could change things entirely. Say, I'm not done yet. I need to keep going. Look at this. You don't even need to stop. You can take this row of numbers exactly as is and synthetic divide another one. Which one do you want to try? Negative. Oh, we know that one works. Let's try one that doesn't work. We'll try positive 3. Well, yeah, so the root of positive 3. Just see what happens, right? So, bring down the 1. Still a 1. 1 times 3 is 3. 2 plus 3 is 5. 5 times 3 is 15. 15 plus the negative 3 is 12. I'm out of numbers. This is my remainder. Shoot, that didn't work, right? So that means positive 3 is not a root. Okay? But look how little space I had to use to check 2 of them right in a row. How did I test, which other problem?
Oh, you just tested it on the answer.
Yes. You take the answer from the first test. If it passes, right, if you get a 0 for the remainder, you don't have to set up a new division somewhere else. You can chain it right off of the last one.
Wait, and you need it. So when we saw these questions, you're making us find every single answer?
Well, if the directions find all the roots, then yes.
But if it just says find the roots?
If it says find the roots, you're finding all of them. If it says find a root, or one root, or check if this thing is a root, then you only have to do one. But this is one tool, right? If you can factor, always factor first. That's the easiest and fastest way to get answers. Okay? Use the part of the remainder theorem, right, was that I can plug in numbers into the function. You can substitute numbers in. If the answer comes out 0, that was a factor. If you find that easier, go for it. The advantage here is that as I find more and more roots, my polynomial gets smaller and smaller, which means the test to find the next one becomes easier, right? Any further questions? No? Okay, then for the rest of the day, you are finishing this synthetic division worksheet. So the first few, Fernando, you'll like these. They just have you divide one thing. That's it. It's just practice. Do the division once. Then we've got some more review. We start bringing in the other concepts from this week, right? Completely factor. What are all the zeros of the polynomial? They give you one of them. You want to find the rest. So synthetic division here is very helpful, right? When you already know one of the roots, synthetic division is a great way forward because it lets you use that root to your advantage to simplify the polynomial and make finding the rest of them easier. So I would start with that. And then here we have, list all possible rational roots. And then you can use that list to start, try dividing things out. Okay, remember the video yesterday, he was setting that up. Said you need a list of things to start dividing, to check. This is the division part. All right, any questions on this worksheet so far? Both pages. Whole thing. All the way through section 4F. All right, you've got the rest of the period to work. Yeah, you guys don't need the Zoom anymore. Okay, and let me know if you have any questions.